Focus question for today. How can you use a number line to compare two numbers? How can you use a number line to compare two numbers? Isaiah. Say it again.
The bell sounds like it's out in the hallway.
You have to borrow one. Here. I'm out today. Your lesson begins on page 11. Turn your textbook to page 11. Turn your textbook to page 11. Rational numbers are numbers that can be expressed as one integer a divided by another integer b, where b is not 0. So what it's saying is rational numbers can be written in fraction form. It can be their equivalent decimal form, because we can put 1 under whole numbers and make them fractions as well, and that denominator is not 0. Then all whole numbers, positive and negative, are also considered rational numbers. Each negative number can be paired with a positive number. That was in your notes yesterday. These two numbers are called opposites because they are the same distance from 0 on the number line, but just in different directions. You're now on page 12. Where would the following pairs of numbers be located on the number line? So what I want you to do now, underneath where you wrote your focus question for today, is to draw yourself a number line. It needs to go from 10.5 to negative 10.5, or you may just want to go from positive 11 to negative 11.
Yeah, which one would be better, 11 or 10.5?
11. John, quickly. From positive 11 to negative 11 on your number line. It asked, where would you find 7 and negative 7? From 0, 7 will be 7 points to the right because it's positive 7. And when we graph a point on a number line, we put a dot on it. Because negative 7 is its opposite from 0, we're going to move in the opposite direction 7 points, and we will graph where to find negative 7. So they are both 7 points from 0 in either direction. Where will we find 21 halves and negative 21 halves? Because I do not have my number line broken into fractions, what will I have to do to 21 halves to figure out where to plot it?
Start in the middle.
21 halves. What kind of a number is this? What kind of fraction?
Improper.
What can I turn it back into?
Improper. A whole number, whole number.
A mixed number. 21 divided by 2. It'll go 10 times with 1 left over. So 21 halves is really 10 and 1 half. So it's asking for positive 10 and a half and negative 10 and a half. Because negative 21 halves would be this number 10 and a half that's negative. So positive 10 and a half will be here between 10 and 11. And negative 10 and a half will be here between 10 and 11. That's where you're plotting. Because it's numbered backwards when you go on the left side in the negative realm, it starts from 1 here, so the numbers get bigger as you move to the left, but the actual amount gets smaller. So the bigger the negative number, the smaller the amount. Then it asks for negative 3 and a half and positive 3 and a half. Where will I find 3 and a half?
In the middle of 3. In the middle of 3 and 4.
Between 3 and 4.
Dang.
So negative 3 and a half will be between negative 3 and negative 4. So that's where I'm finding that number that they've given. And then the last pair is negative 1 half and positive 1 half. Where will I find positive 1 half?
Well, what is it?
Between 0 and 1 is 1 half. Between 0 and negative 1 is negative 1 half. So they're the same distance from 0, just in opposite directions. Now, in 6th grade, some of you have graphed inequalities before. And we are not going over how to solve an inequality right now, but they want you to see when you graph a set of numbers, and it's going to look a lot like graphing an inequality. When you graph a whole set of numbers, what it looks like. So I'm going to erase this one, and we're going to make another one. And you can do this on the back of your worksheet. There's plenty of room at the bottom or underneath where you wrote your focus question. This one needs to go out to 15 and a half. So out to 16. Just make your increments closer together.
That's bad.
I'm not in the business of wasting time. That's why I'm fast. I've also had lots of practice. 16 to 16.
I was doing.
Okay, now what it has asked me, they may need to separate, is how would I graph a set of numbers, set of all numbers, that is less than 4 on a number line. Did it say that 4 was included? The set of all numbers less than 4. Is 4 included? No. If it's asking me for all numbers less than 4, 4 is not included. I would put a circle over positive 4. And because it's not included, it would be an open circle. If 4 was included, I would have colored it in, and that would have told me that 4 was in that set. Now it said all numbers less than 4. Which direction do the numbers less than 4 go, left or right?
Left.
To the left. So then you fill in that whole number line to graph the whole set of numbers that are less than 4. And some of you are going, oh, now I remember doing that, because you did it last year. The next one asks, how would I graph the set of numbers that's between positive 1 and negative 15 and a half? Are positive 1 and negative 15 and a half included?
No.
No, because it said between those two numbers. It didn't say those numbers were included. So I would put a 0 or an O around 1, and it would be open because 1 was not included. I would put a circle around 15 and a half, negative 15 and a half, and it would be open because it was not included. And it said all numbers in between it. So then you would color in the number line there. And typically these would be done on different number lines, but to save us some time, we did it on the same one. Selena, you have a question?
So you put 0 in between 0 and 1. You put the second between 0.
On 1. Because it asked for the numbers between 1 and negative 15 and a half. So that's where my circles went over. 1 and negative 15 and a half. And it wanted all the numbers between. Those numbers were not included, so they were open circles. If those numbers were included, I would color the circles in. And we're going to be doing some practice with that when we get to letter E in our problem today. Any questions before we begin our problem? Okay, you are on page 12. Number 1 asks you to estimate the values for points A through E on that number line. So what you're doing now is on your recording sheet, you're telling me where A is at on that number line, where B, C, D, and E are at on that number line. You have 1 minute to do that. Guys, we shouldn't be talking, we should be working.
I thought that paper and John was saying.
Yeah, because you're trying to look at it, but I'm trying to get this.
Hand it to Miss Williams, please, and get on task. Is on -7. Remember, they are numbered backwards from 0 left. The 7 is before the 8, going from right to left. B is on -4. C is on -1.5. Very good. D is on +4.5. And E is about 6 3/4 positive. It is greater than 6 1/2, so whatever your decimal is needed to be greater than 0.5, because you can clearly see that that dot is further than halfway. So as long as you had a decimal that was greater than 5, I would have given you credit for that.
Like 6?
6.6, yes. Number 2 wants you to now state the opposites of these numbers for number 2. So if A was a -7, what's the opposite of -7? +7. We're just changing the sign. -4, a +4. -1 1/2, +1 1/2. +4 1/2, -4 1/2. +6.75,
-6.75.
So we were just stating the opposite. Same distance from 0, opposite direction. Now, number 3, I've left you room on your recording sheet to draw your own vertical number line, or you can flip it over and draw you a vertical number line. So number 3, you need to draw a vertical number line, like a thermometer. I'm going to number mine in increments of 10. And I have to go all the way up where I can get +115, and all the way down where I can get -32.7. That's my smallest temperature. So you can do it in the increments that you want. I'm going to do every 10. Because 115 is my highest temperature, I can stop at 120. Because -32.7 is my lowest, I can stop at -40. It wanted you to draw a vertical number line. A thermometer can be thought of as part of a vertical number line on which values above 0 are positive. It wants you to sketch a thermometer, a vertical number line, and place the following temperatures on it. It does say to explain how you decide where each temperature should be placed. And I'm going to give you a moment to put those temperatures on your number line where you think they should go. Say it again, Selena.
On the wood.
Bottom -40, top 120. Zero degrees, you're going to plot it here in the middle. 0 at 0 degrees. Positive 115 is between 110 and 120. It's halfway between. Negative 15 is between negative 10 and negative 20. Negative 32.5. I know that negative 35 is between negative 30 and negative 40. Negative 32.5 is closer to negative 30. Positive 40. 40 above 0. Positive 113.2. I know it's got to be below 115, but not all the way down to 110. And negative 32.7 will be even colder than 32.5, than negative 32.5. So this is where your point should be on your vertical number line when looking at the temperatures in number 3. Any questions about that one? Number 4. How do the number lines from 1 and 3 help you find which of those two numbers is greater? On number 1, which number was greater? 6.75. So for number 4, E was greater in number 1. And which temperature was the greatest?
120.
115 degrees Fahrenheit.
Yeah.
Now it asks, how did those number lines help us to identify where those greater numbers were? Because E was the farthest to the right, and because 115 was the closest to the top. And that's how we use number line and position to find the greatest number in number 1 and in number 3. Any questions about A before I erase it? Go ahead and draw another number line for B. And we're going to use the same one for the whole letter for all of B. So it's got to go from 10 to negative 10.
Alright.
So D, a number line from 10 to negative 10. Martin, quickly. Drawing a number line from positive 10 to negative 10. For each pair of temperatures that they have given you, identify which of the two temperatures is the further from negative 2 and explain how you decided. So what I'm going to do is circle where negative 2 is. The whole point is to use a number line, like the focus question says, to help us solve these problems. So if I have to compare numbers to negative 2, I want to make sure I know where negative 2 is at. The first two that it wants us to look at is positive 6 and negative 6. Positive 6 is here, negative 6 is here. Which one is further from negative 2?
Negative 6. I meant positive 6.
Positive 6. If you can't see that this way, then you actually count off. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So it's definitely positive 6. So for B, number 1 is positive 6. The next set of numbers it wants us to look at is negative 7, and positive 3. Which one of these two is the furthest from negative 2?
Negative 7. Negative 7.
This one's a tricky one.
Wait.
Count it off. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Equal.
They're equal distance. So negative 7 and positive 3 are both the furthest point from negative 2. That's why you can't go just on how it looks. Count it off. Use the number line. The next set of numbers is positive 2, and negative 7. We're going to count it off. 1, 2, 3, 4. 1, 2, 3, 4, 5. Which one's further away? Negative 7. And the last one for B, the two they give you is negative 10, and positive 7.
1, 2, 3.
So we're going to count it off. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which one's further away?
Positive 7.
Positive 7.
Okay.
Really?
Okay. I'm going to use the same number line. No, I can't. It's got to go to 15. We're going to draw a new number line for C. But again, you got to be faster.
Does he look like what?
Which one do you need?
Guys, right here. You're drawing a number line on the back that goes from negative 15 to positive 15.
Okay. Thank you. I'm going to write that. I wish you
Identify the temperature that is halfway now between each pair of temperatures, and again we can use a number line to do that. So 0 and positive 10. 0 and positive 10. What number is halfway between? This is C. One, two, three, 4, 5. 1, 2, 3, 4, 5. Positive 5 is halfway between 0 and positive 10. Any questions about how to use the number line to do that? Number 2, between negative 5, which is here, and positive 15, which is here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I can go more. 1, 2, 1, 2. Again, I'm at positive 5. And I have used my number line to find that halfway mark. Number 3. Number 3 is positive 5 and a negative 15. What is the number that is between a negative 5, a negative 15, and a positive 5? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I can go more. 1, 2, 1, 2. Negative 5. Isaiah, quickly. Number 4. What number is between negative 8 and positive 8? Those are opposites. 0. So you would go positive 8 this way, negative 8 this way. You would end up there in the middle. Zaire, if you guys keep talking, I'm going to ask you to leave. This is C, 0. Now D does not require me to do anything on the board because it's going to require you to think. Integers are also used in chemistry. For example, a hydrogen atom has 1 proton, which has a charge of positive 1, and 1 electron, which has a charge of negative 1. The total charge of a hydrogen atom is positive 1 plus negative 1, or 0. It wants you to describe 3 more real-life situations in which opposite quantities combine, which means you're adding opposite numbers to make 0.
A battery.
Now, remember, positive and negative numbers are used in money. Positive and negative numbers are used in altitude, above sea level, below sea level. Positive and negative numbers are used on a thermometer, above 0, below 0. In golf, they're wanting you to come up with real-life situations where you will be adding opposites to get back to 0. You've got to come up with 3. So here is my example. I have no money in my bank account. Yesterday, I deposited $100. Today, I withdrew $100. I am back at 0. That is a real-life situation where adding opposites will get me back to 0. So I'm going to give you just a few minutes to come up with those 3 on your own in Part D. There is 1 line for each for you to fill. Real life situations. 3 of them. Okay, let's look at E. Recall that a graph of an inequality is a sketch on a number line on which possible answers are shaded. We did that in the launch. For each part, you're going to graph the possible solution for X on a number line. I have provided you with the number lines for 1 through 6, E. Number 1 says that X is positive. So that's going to be all positive numbers. So your circle will go around 0. Is 0 included in a positive number?
No.
No. 0 is neither positive nor negative. So it's going to be open. And in which direction do I shade for positive numbers?
Right.
To the right. So it will be shaded this way. That's all you do.
Really?
So that's all you do? You just color in one
That's
line?
all positive numbers shaded on that number line.
Oh, that is right.
Number 2. Now listen to the qualifications. X is less than or equal to -5. So I'm going to put my circle around -5. Is it equal to -5? Is -5 included here?
Yes, no.
Read it again.
Yes, 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 yes.
X is less than or equal to -5. Because -5 is included, I have to color it in. And then it said it is less than. Which numbers are less than -5? To the right or to the left?
The
Left.
To the left.
To next.
These numbers are smaller, so we graph all the rest of those negative numbers. Yes. No. Number 3, X is less than -7. So now, I'm at -7. I'm going to put my circle over -7. Is -7 included?
No.
No. Then it says X was less than 7. Which numbers are less, right or left?
Right.
Left.
Good.
No, I really put the paper down. I said it wrong.
Number 4. X is greater than or equal to +5. I'm going to put my circle over +5. Is +5 included here?
Yeah.
Yes. It says greater than or equal to. So I'm going to color in because 5 is included. And if X is greater than, which direction do I color greater numbers?
Right.
To the right. They are bigger. Number 5, 6 is less than X. Now, anytime my X is not on the left, I get confused. So, I read it backwards, and I start reading it from the X. So, this is another way to read number 5. X is greater than 6. So, I know that I need to put my circle around 6. Is 6 included? No, because it said that X was greater than 6, not that it was greater than or equal to. Now, what numbers are greater than 6? To the left or to the right?
To
the right.
To the right.
We're not going to go with the trick because the trick only works when the X is on the left. And you obviously see they're going to give you ones where the X isn't on the list. Then, when you look at number 6, again, they've thrown that X over on the right. And you've really got to think about it if you read it starting with the 6. So, read it backwards if it helps you. This actually says that X is greater than or equal to -1. So, I put my circle on -1.
Close.
It is closed because it is included. It said that it was greater than or equal to -1. Now, what numbers are greater than -1? To the left or to the right? To the right.
To the right, to the...
And so that's how you would graph number 6.
So 6 would go to what? I can't see.
6 is colored on -1 because -1 is included. It is a closed circle,
So,
and it is greater than -6 and includes -6. So, I mean, -1. So then you would color the line to the right. Selena,
and then I have another question. What would be F1 on that line?
we haven't done F1 yet. Right now we have just finished E6. I have F1, F2, and F3 here to solve, and then it does want you to graph it as well. Really?
Which is why equal?
Not funny.
No, that's like...
So it's not one right there? X plus 5.
Okay, when you see inequalities like this, these inequalities have not been solved. What you just saw in E were answers to inequalities. Sets of numbers that X equals. These want you to solve them to get those answers and then graph them. Some of you have solved inequalities before in 6th grade and some of you have not. You solve them the same way that you solve equations. You look at it like it was a balance. What's been done to X? You have added 5. What's the opposite of add? Subtract. So we're going to subtract 5 from both sides. That cancels, it leaves X by itself, and you simply drop that inequality sign, just like you would drop the equal sign as you go down. Now, there are rules for integers, and I'm going to go ahead and tell you the rule for subtraction. We looked at it yesterday. It's adding the opposite. So if I added -5 to 0, what do I get? -5. So this is the answer. So what my graph would look like is I would have my circle on -5. X is greater than, not including -5, and it would go in this direction. Now, this is just introducing you to solving inequalities. When we get in the next book, you're going to learn how to do multi-set inequalities. And you will also already know your integer rules when we do those. The question was asked this morning, well, how are they going to test us on graphing inequalities? Well, they'll give you something like this, and then they'll give you one of these for A, one of these for B, one of these for C, and one of these for D, and you have to pick which one matches this. So they do ask you about these on the EOG. It's grade level. This one, here is the balance. What's been done to X? We have subtracted 1. What's the opposite of subtract? We're going to add 1 to both sides.